There are billions of stars in the universe, but only one dominates our galaxy. That's the Sun. It's a hellish sphere, mainly composed of a nuclear sea of hydrogen, high-temperature plasma, burning at millions of degrees. His surface is filled with violent explosions, millions of kilometers into space, ejecting a deadly radiation storm. Our Sun is a kind of perseverance known as a yellow dwarf. Yellow is because of the color on its surface, and dwarf because it's too small for a star, but small is relative. It could hold 1.30 million Earths. In our solar system, there is no star bigger than the Sun. Its diameter is 1.39 million kilometers. It's a giant celestial bomb. The Sun is really huge. It dominates our solar system. Not only is it the largest star in the solar system, it is also the only star in the solar system. It is surrounded by a swarm of smaller stars. We call them planets, comets, and satellites. The Sun is our star. It's a huge source of heat and energy. It has a surface temperature of about 5,500 degrees centigrade. The total power radiated by the Sun is 380 billion megawatts. It makes everything about human beings seem insignificant. Hoover Dam in Nevada can only generate 280 trillion watts. The amount of energy the Sun generates in 1 second than the entire human civilization. It uses even more energy. This energy is generated in the blink of an eye. It's incredible. The Sun has been burning this way for billions of years. Early astronomers didn't understand how it worked. How does the Sun generate energy? In the early 19th century, scientists believed that the Sun is like fire on the Earth. There is a source of fuel. Maybe the coal is burning slowly, but there's a serious problem with this theory. If there is a fire in front of us, if we want him to keep burning, we need to keep adding wood to it. This fire may only burn for an hour. If we had firewood as big as the Sun and burned with enough oxygen, it will burn up in 5,000 to 6,000 years. That's a long time, but not enough to sustain life on Earth. By the early 20th century, a method of exploring the adhesion of Earth rocks and fossils. The existence of the Sun has been confirmed, and the temperature of the Sun is warm enough to sustain life, but not for thousands of years, but for 60 billion years. If you want to give birth to someone who can live for so long, you need a lot of wood. It's obvious. There must be other processes unknown on Earth, providing burning energy to the Sun. 1920s scientists have found the answer to this mystery. This process was later used to create hydrogen bombs. It's nuclear fusion. When atoms collide at high speeds, fusion occurs. To do this, the conditions have to be just right. These two protons each carry a main chamber, and so they will be mutually exclusive. This requires getting them close enough to do this. It needs to have enough temperature that makes the particles go really fast. When the density is high enough, they will get close enough and will collide with each other. A sea change occurs. Core of the Sun. It's the perfect complement to produce fusion. It's the hottest place in the solar system. Temperatures up to 15 million degrees Celsius, and it's very dense. You would think that at these densities, the core of the Sun should be solid, but because the temperature is too high, so there's a plasma state. If the gas is heated to a high enough temperature, the electron is separated from the atom. They will float in the liquid. Therefore, its form is different from that of key, body. So we have a different word for it. We call this plasma. To really understand what's going on in the core of the Sun, we have to imagine it. Things that are almost unimaginable. The Sun is a place with an infinite number of particles. They collide, interaction. It really is like a space pool table on an unimaginable scale. No matter how hard you hit the ball, you can never hit the ball hard enough to make a ball blend with another ball. But the pressure on the sun's core is too great, it's too dense, so that the two objects collide with each other. There will be a sea change inside the sun. These objects are hydrogen atoms, bumped together under tremendous pressure, forming harmful atoms. In the midst of this upheaval, the atoms produced less mass than their pre-fusion atoms. The lost mass is released as energy inside the sun, 600 million tons of hydrogen atoms per second, into 595 million tons of seaweed. In the process, the lost 5 million tons of mass is converted into energy, equivalent to 1 million ton hydrogen bombs. The released energy, so we now know the sun is powered by nuclear fusion. It's the only fuel we know of. It keeps the sun burning. Enough life on Earth to last for billions of years. Sunlight is so important to life, so much so that we rarely think about him. But how did light get from there to here? It's an incredible story. The energy generated during nuclear fusion, made up of photons called light and heat, passed through the core. They bring warm sunlight to the Earth to reach our planet. These glowing travelers, winding from the center of our nearest star, through the layers of the sun. First photons enter the radiation zone. 300,000 kilometers later, it's a very dense area, so that photons keep hitting other particles, such as clearing atoms and high atoms. He floundered outward in a chaotic and disorderly pattern. Scientists call this a random walk, a photon. And without having to interact over and over again, there is no escape. He will be absorbed by atoms, and then it's changed again and again millions of times. As you get further from the core of the sun, the lower the density, the fewer collisions and interactions there are. When the photons finally arrive, within 210,000 kilometers of the surface, photons enter the sun's troposphere. Photons are carried upwards by the boiling gas in a huge column of air moving at hundreds of kilometers per hour. It only takes 10 days. The photons will reach the surface of the sun when photons emerge from the atmosphere of Sun Cyber. When launched, this incredible journey, we're almost at the end. From there, he only needs about 8 minutes through 150 million kilometers of space to reach our planet. It's incredible. When sunlight actually reaches the Earth, if he hadn't existed for millions of years, that's been around for hundreds of thousands of years. For the sun, even 1 million years, it's just a blip in time. A simple but perfect sunset overshadowed the long and violent history of our star. The sun is a ball of fire. Billions of years ago, born in what's called a supernova explosion. In this star, many times larger than the sun. After the explosion, a giant gas nebula many times larger than the solar period. Small pieces of matter will gradually gather in this huge cloud about 4.60 billion years ago. This nebula, under the attractive force, start exploring our solar system. Perhaps it is by such a self-attracted gas. He pulls himself together and gradually rotate in the process, like a skater withdrawing his arm while spinning until the stars and the various planets around them merge together. Eventually, when the star is dense enough, fusion occurs, start to shine and release sunlight. Why do scientists believe the sun was born from the ashes of a supernova? The evidence is at our feet. To extract from the Earth oil used to fuel nuclear power plants. Such a complex heavy element, impossible to make on the sun because a star of this size, there is not enough heat to generate more heat than iron. Heavy element. Heavy elements such as oil can only be produced in a devastating cosmic explosion. Earth and other planets in the solar system are made by the same group that produced the Sun Nebula formation. In the process, the sun accounts for 99.86% of its mass. This means that it's the largest object in our neighborhood, the most attractive force. That's why other celestial bodies are surrounding him. Of all the planets, Earth earned a special position relative to the sun. If we were closer to the sun, the oceans will evaporate, the ground temperature will also be high enough to melt lead. If we were further away, our planet will be a frozen wasteland. We're 150 million kilometers from the sun. We're happy to be here. We are also lucky to be here. In a sense. Here we are, because we have the right environment here. The position of the Earth in the solar system. Maybe just right, but we're close enough to the sun, enough to be the target of its anger. The sun occurs every year, thousands of gigantic eruptions. You might think this jetting force comes from nuclear reactions in the core of the sun, but in fact, what drives the sun's eruptions is magnetism. Since the Earth rotates as a solid, so our magnetic field is very simple. We have two poles, north and south. That's why the compass. For you to find your way around the Earth is such a useful reason, but imagine this, if not 2 words, but 1 million to 10 million. This is what happens on the sun. The sun's magnetic field is like a torn web. Even though he is held together by gravity, it's not going to be evenly distributed. Equatorial barrier. It goes around every 25 Earth days. The plasma at the poles lasts about 35 days. Circle around the sun rotates by what we call a differential rotation. There's so much plasma, they don't rotating the surface of the sun at the same speed and cause the magnetic field lines to become distorted, the resulting interweaving and mixing. Although the magnetic field lines are invisible, but we observe rising into the sun's atmosphere, characteristics of the ring and the solar ear. Know that they exist on the sun. It's like metal being unloaded onto a simple magnet. The arrangement appears to be the same. These circular plasmas finish. The beauty outlines the magnetic field structure that supports them. These plasma arcs are high and wide, can make a planet as big as Jupiter. Pass them through the middle. Magnetic fields can sometimes plasma in the solar atmosphere twisted into a majestic spiral. It's called a flux latch. A flux latch is a bit like a spring. The magnetic field lines are wound in helices many times. When magnetic field lines are highly distorted, it carries and stores a large amount of free magnetic energy. Sometimes he even twists himself into a ball, which allows him to store more free magnetic energy. The solar ears of these plasmas can last for weeks or months, but eventually the stored energy must be released. This is how matter is ejected into space. The magnetic field of the sun is most twisted, song in the most complex places. The heat gushing from below is locked by a magnetic field. Matter is gradually cooled by 1,000 degrees. The result is that on the surface of the sun it forms a relatively dark spot. We call them sunspots. Sunspots are only bright around. Compared to bright matter, it looks dark. If you could place it alone in space, his light will be 10 times brighter than the full moon. These look like tiny spots on the surface. It's actually the size of the entire Earth. Galileo was the first to observe the sun. One of Sunspot's modern scientists. He used a telescope to image the sun project onto paper and depict. He realized that these spots are moving across the surface of the sun. This was the first sign of the sun's rotation. Not only does the sun rotate, sunspots themselves can also act like hurricanes, rotating on the surface of the sun. When such a situation arises, their magnetic field lines are extremely distorted. Distorted magnetic field lines mean more energy. More energy means the potential for a huge eruption. We think of rubber bands as magnetic field lines. When you twist it to a certain extent, it will store energy. When you let it fly, energy is released. If it's just a loose rubber band, he can't fly. When the sunspot releases its magnetic energy, it would generate the largest explosion in the entire solar system. Fried, this is the sunspot. A single patch can release 1 billion megatons of energy, equivalent to the Earth. The total energy of 1 million volcanic eruptions. There's some bright spots appearing there. The reason why it's so bright is because of the high temperature. About 10 million steps, and it can last for hours, but the energy is enormous. The entire eruption process. That's the equivalent of millions of nuclear bombs, and they drop it onto the surface of the sun. The released energy. Solar spots don't just erupt into space. High energy particles collected into the chromosphere of the sun. Right there. They'll be like cue balls in a pool game. It's the same as hitting the placed subball. Rapid transfer of energy. When you have a cue ball, in fact, it is equivalent to a high energy particles from the patch region. The cue ball will be like a billiard ball on tee. Hit the daughter ball, the energy is quickly transferred to the ball behind. Then all the balls will be knocked out. If a patch shoot enough energetic particles at the same time, amazing things happen. This is a real image of the sun's earthquake. In 1998 in Japan, Myanmar, and China, a special sun patch appeared. His power is so great, materials that impact the surface of the sun. It's literally smacking against the surface of the sun. Cause ripples there, although they look like ripples on the water. But they're actually 3-kilometer high waves. The fastest diffusion rate can reach 400,000 kilometers per hour. The 1998 solar earthquake. The magnitude of the earthquake detected was 11.3. This is bigger than the 1989 San Francisco earthquake, more than 1 million times stronger. In order to make the surface of the sun vibrate so violently, the sunspot must release a tremendous amount of energy. If you put this energy on the Earth, this is equivalent to using explosives about 0.9 meters later, covered the entire continent of the Earth. Then it all detonates at once. So these explosions are quite powerful. Earthquakes are not the only ones. Natural disasters that occur on the sun, plaques can also cause solar tsunamis, plasma waves in the solar atmosphere. At 1.10 million kilometers per hour, affect the sun spreads across the surface of the star in a matter of hours. Although earthquakes and solar tsunamis do not affect the Earth, pose a threat. But the intense activity of the sun often triggers some dangerous eruptions. It's called a Japanese cotton mass ejection. During the Japanese cotton mass ejection, the energy of the patch will turn a ball of high electric brown radioactive plasma is ejected from the solar atmosphere. The range of Japanese cotton mass ejections is very wide, but their speed at 1,200 to 1,400 kilometers per second. Do a spray, it's very fast. He'll eject a lot of material. The mass of the ejection can be compared with Mount Everest thrown on the surface of the sun and sent into space. When this hot mass of radioactive plasma, when leaving the sun, where will he fly to? Sometimes he would fly innocently into space. Other times, it may be close to our home. Solar projectiles. Maybe you've never heard how dangerous this can be. This is called a solar storm. A solar storm erupted by the sun. A large number of charged particles thrown 150 million kilometers into space. Most travel from the sun to the Earth. It will take a few days, but some go 60 million kilometers per hour. Through the solar system, reached our planet in less than 16 hours. These storms can generate electrical currents in the outer atmosphere, sabotage satellites and power grids across the country. It could be like a hurricane or a tornado, wreaking havoc on our infrastructure. How can we monitor the shower room? What about this potentially dangerous cosmic explosion? There's a little-known group of forecasters in a place called Space Special Department Work at the Environmental Center. Their main job is to monitor the sun and issue forecasts for dangerous solar activity and early warning information. These space forecasters are on high alert because if a solar storm could destroy life on Earth. Solar storms are made up of charged particles, so they will initially be attracted by our magnetic field. Transferred around the Earth, it's like a ship sailing with its bow open. If he directly affects our outer atmosphere, a small part of the atmosphere, hit into space. One reason why Mars doesn't have a dense atmosphere, it just doesn't have a strong internal magnetic field. Therefore, over millions or even billions of years, atmosphere on sun peak and solar mass, ejections, gradually drifting into space. But our magnetic field, not a department. The perfect shield in fantasy movies. Some particles can penetrate magnetic fields, go to the upper level to cheer up solar storm. Even the magnetic field lines on the other side of the Earth, it bends and breaks. Charged particles will follow the fractured magnetic field lines, move towards the north and south poles. Extremely powerful solar storm will further distort the Earth's magnetic field, and it generates electricity across the entire continent. When this happens, it's like a high-voltage long-distance transmission line. It's overloaded. It will damage the transformers at both ends of the line. In fact, in 1989, Canada, most of North Carolina was without power because the transformer was destroyed by the solar storm at that time. Destroyed. If a storm strikes our communication system, there will be all kinds of chaos. If power operators have time to respond, they can reduce. Avoid disaster by running electricity through wires. Satellite operators can also use appropriate warnings. Prepare for a fierce attack. When a powerful solar storm comes, they will put some satellites into a dormant state so the storm doesn't generate electricity, air shorts, or otherwise destroy satellites. So the longer the warning, the better. Solar storm. Also interfere with the use of aircraft, high-frequency radio communication. In the 1980s, when a solar storm strikes, Air Force One is transporting President Reagan to China. All communication was down for a few hours, effectively cut off the communications of the head of the US government. Due to the fact that magnetic counties come from the Earth's south and north poles, the power of a solar storm. These areas are easily accessible. For this reason, scientists are concerned that during severe storms, passengers in an aircraft flying over 2 levels may be exposed to harmful levels of radiation. That could be the equivalent of 100 chest X-rays. The threat of solar radiation. They're just scientists. Another reason to keep an eye on the sun, especially in modern times. What the sun is doing is particularly important. The Earth is not an island. We are participants in any activity in the solar system. Sunspot is the trigger for more severe solar storms, so as they spin across the surface of the sun, air marshals and forecasters will track them carefully. We see solar projectiles all the time. As the sun rotates, many sunspots come from the north face of the sun. It's not Earth-facing, so it's not going to affect our planet. Too much impact. As the sun rotates, active regions are getting closer to the center of the equator and face us. That's the great danger we need to be aware of. It is also accompanied by amazing beauty. Solar storms generate spectacular planetary light shows, sparkling, colorful light curtains called auroras. Lasers are like neon lights on a massive scale. In a neon sign, current. Introduce charged particles into a gas-filled tube. The particles in the gas are excited and start to emit light. If there's only milk in the tube, he will glow red by adding other gases. For example, Asian gas. It can produce all sorts of colors of light. Neon sign. It's powered by a power plant inside the tube. However, the aurora. In fact, it is generated by magnetic fields and energy from the sun, driven by luminous. When high-energy particles in a solar storm, when flowing along the Earth's magnetic field to the north and south poles. They excited the elements in our atmosphere, make them shine. The nutrients glow green or red, but the molecule turns pink, blue and purple light. Although these ghostly lights are usually limited to the polar regions, but a severe storm drive them closer to the equator. In 1859, a massive solar storm, the laser generated as far as Rome in the south. This solar storm. Let's further understand the charm of the sun. The storm is so intense, so perfect when combined. He completely ignored the natural defenses of the Earth. A huge sunspot, exploding on the surface of the sun. Less than a day later, 150 million kilometers away, the cables that carry Earth's communications and electricity start to spark, so we have a global context. Business activity comes to a standstill. At the same time, colorful aurora lighting up the skies of cities around the world Earth. Just weathered a perfect solar storm, the sun triggered incredible solar spots, and a huge amount of energy rushed towards the Earth. This storm is not only the largest on record, one of the most powerful two games, it's also the fastest. He ejected directly from the sunspots to the Earth. In less than 18 hours, fly from the sun to the Earth. Fortunately, the perfect solar storm happened in 1859, the only thing vulnerable. And the technology that mattered was the telegraph, since we started. Since the age of high technology, we haven't met yet. Another perfect solar storm. What matters is whether this will happen again, and the answer is yes. Compared to 1859, the impact on us today could be devastating. The impact on our communication system on Earth. We haven't figured it out yet. This is true for modern society. The scariest place. Our modern technology, it will probably be like the beach during a typhoon. House destroyed. Imagine that. If we lose all relayed cell phone calls, television signals, and satellite banking transactions, at the same time, grid failure, causing the entire area to be trapped for hours, even weeks of darkness. If these essential services are not restored quickly, then chaos is not far away. This will definitely affect society, and everyone who lives on this earth create a chain reaction. Solar storms are as unpredictable as typhoons, although space forecasters lack of technology to predict the next perfect storm, but they do. The next storm is more likely exist during the sunspot activity cycle every 11 years. The sun goes through a cycle every 11 years, will change the direction of the magnetic field. So after 22 years, returned to his original position. Every 11 years. As we approach the sun's magnetic field reversal, the number of sunspots will increase. There's a spike in solar activity. We call this cycle the period of solar activity. There is also a cycle interval of about 5 years. We call this solar inactivity. So in these 11 years, the sun can be very fierce at times, can get manic. Sometimes the sun's activity varies. Some storms are more powerful than others, although it is currently in a period of minor solar activity. But scientists are taking a closer look. Next time too, what kind of chaos can Yang activity cause? The last peak of solar activity, it was around 2001. The next time should be in 2012, but maybe not. The field of solar physics is basically in C West. Let's see what happens. For what will happen next? People have very different opinions. A research team believes that the next solar cycle, possibly the most powerful contemporary. If these predictions are correct, the Earth is about to go on a crazy journey. We have to worry about a repeat of the events of 1859. If it happened today, would cause immeasurable damage. We will learn a lot. The sun's impact on modern technology. Knowledge of what the impact will be. Most of the sun's eruptions occur, known as the hellish outer layer of the sun. This area has long been, it has always been a great mystery to the sun. Even if he is far from the core that generates heat, 800,000 kilometers away, he still burns at millions of degrees. This seems to violate the laws of physics. It's very strange. If we place the thermometer probe close to the fire source, his toxins will rise. The detected temperature exceeds 200 degrees humidity. If we move the probe a little further away from the source of the fire, it will drop to about 90 degrees. Now, the further away from the fire, the cooler it gets. But in the atmosphere, the sun is as hot as its core. What kind of power will it cause the temperature in Japan and Myanmar to be so high? The answer will surprise you. Hellish Japan reaches millions of degrees. Over the course of centuries, scientists have never understood. Why is it so far from the core of the sun? Matter still burns so hot. The recently improved satellite provides the impact of getting closer to the sun's surface. Clues are starting to surface. The surface of the sun beneath the corona is actually. The reason for the boiling is the entire surface of the sun is covered by convective motion. Convective motion is the hot matter inside the sun. Rise to the surface of the sun, cooling by luminescence. Let out the sun. Then the cold material sinks back into the interior. Every bubble that appears, it's the size of Texas. He spreads to the surface of the sun, it cools down and sinks in 5 minutes, so this is a very violent process. In fact, on the entire surface of the sun, almost 1 million places. That's what's happening. It's happening all the time. This boiling on the surface of the sun is not only violent, and it was really loud. The sun is actually a very noisy place. It's like covering the entire surface of the sun with a loudspeaker. It's like nothing you've ever heard before. The loudest interpretation of rock music. The churning of the sun's surface generates enough life energy, heating the temperature in Japan and Myanmar to millions of degrees. Scientists believe that these sound waves, combined with energy from the sun's magnetic field, it's Sunday Burma. The main causes of extreme temperatures can make you the only one from the Earth. When you see the corona is in the solar system, one of the most stunning astronomical sights, that is the time of the heliocentric master. Before scientists knew anything about them, these awesome events, it just creates fear. The ancient Chinese believed the dragon is devouring our sun. So, what happens to the eclipse? And the simple answer is this: the moon blocks the sun's rays. Imagine that, when you're sitting in the cinema, watching a movie, very happy, looking at the screen being played, and then someone in the row in front of you walks over, blocking your view. We are lucky that the moon and the sun will meet. Also lucky. The moon passes right between the earth and the sun. We were lucky. The moon is 400 times smaller than the sun, but it's also 400 times closer to us. This cosmic coincidence implies that these two celestial bodies are in our sky. They happen to have the same appearance and size. This makes an object can completely obscure another object. This spectacular astronomical event, only on the moon, at a focal point between the Earth and the Sun will happen. The moon's orbit is slightly cleaner by about 5 degrees. If not once a month, there is a sun corpse. Then we would be bored. But we didn't get bored, because most months, moon all above the line between the Earth and the Sun or below. So it's not a circle time every month, but only once a year and a half. When the moon passes in front of the sun, he casts a shadow on the earth. The darker part of the outer shadow, we call it the penumbra. As the penumbra moves along the surface of the earth, if you stand in the shadow of the penumbra, then you can only see the daily time. But if the path of the lunar umbra, just passing by where you are, you will experience the most spectacular sight of the solar system. If you can't get there, on the path of the whole city, there is another option, that is to wait in one place. Long enough, about every 300 years, there will be a total solar eclipse passing over your head. The sun is the only shining star in our solar system. The sun is stunningly beautiful and fierce mutilated violence. It all seems unbelievable, but he won't last forever. Eventually, our sun will die too. The core of the sun contains a fixed amount of fuel. A simple calculation can tell when will the sun enter the extinction stage. About 5 billion years later. Unfortunately, the sun doesn't go away with a bang. He's too young. A super novelty outbreak is unlikely. But there's something strange about stars. They get hotter as the temperature drops. When the sun was fueled with hydrogen, our nearest star will cool under gravity and gradually explore. The energy generated will reheat the core to extreme ease. As the heat gradually increases, enough to start burning the extra heat generated by harmful combustion, the star will expand into a giant sphere known as the red resolution. When the sun will become very large, will engulf the entire planet, Mercury, Venus, and Earth. You don't want to be there. Before this happened, we need a way to jump through the planets. Go to a safe place. As stars expand, the Earth needs to slightly change its orbit so he won't be swallowed up. The Earth's temperature is rising. You definitely don't want to be here. The sun's outer layers will eventually become very unstable. They will be launched into space, leaving behind a core about the size of the Earth. Our once great sun becomes a slowly cooling afterscene. All known life on Earth will cease to exist. This is the death of the sun. All of this is bad news for humanity. But look on the bright side. We have 5 billion years to prepare for this disaster. Humans on Earth today, bathed in the radiance of the prime of the sun. Science has met the secrets of our nearest star, but we are still in awe of his beauty. Be more vigilant against the wrath of the sun.